where people have sort of used robots to do these inspections.
These sensors will be very quickly able to tell you.
So very interesting that we left it for curing.
Hello, good evening everyone. Am I audible clearly? Hello?
Yes, sure.
Hello?
Yes, you're audible,
Good evening
others.
everyone. We are the CEST Club of NIT Rourkela in collaboration with ICE United Kingdom's NIT Rourkela chapter bring to you a brand new session of CIVINAR, and I, Adarsh, am the moderator for today's session of our very successful initiative, where we welcome eminent personalities from different fields of civil engineering for highly intuitional webinars. Our previous sessions were graced by Professor Sriram Narasimhan from the University of Waterloo, Canada, Professor Nemi Bantia from the University of British Columbia, Vancouver, Canada, who also happens to be the scientific director of IC Impacts Canada, Professor Rishi Gupta from the University of Victoria, Canada, and Professor Chittaranjan Ray from University of Nebraska, Lincoln, who gave their insightful talks to our student community. But before we begin our webinar, I would like to call upon Mr. Satyadeep Mahapatra, President of the CEST Club of NIT Rourkela and the convener of CIVINAR Organizing Committee, for a welcome address.
Hello, am I audible? Hello. Okay. Thank you, others. As winter sets in, a warm evening to all of you present here. This is Satyadeep Mahapatra, President of CEST Club of NIT Rourkela and convener of CIVINAR Organizing Committee. Coming about CIVINAR, it is an online webinar cum talk session organized by CEST Club of NIT Rourkela in collaboration with IC UK NIT Rourkela chapter. It is hosted via YouTube Live. The purpose of CIVINAR is to provide the entire civil engineering community with a diversified platform to gain and share knowledge about certain trailblazing topics of current and future interest in the field of civil engineering by noteworthy personalities who have attained expertise in their respective domains. This evening, from our institute, NIT Rourkela, we are joined by Professor Pradeep Sarkar, reputed professor from Department of Civil Engineering, NIT Rourkela, and Chief Patron of the CIVINAR Organizing Committee, and Professor Kakuli Karar Paul, Associate Professor from Department of Civil Engineering of NIT Rourkela, with specialization in environmental engineering. Thank you, sir and madam, for joining us tonight. As mentioned by others, distinguished professors from all around the world have graced our seminar. Adding another feather to our crown, today we are joined by esteemed Professor Rajasekhar Balasubramanian from the prestigious National University of Singapore. I feel proud and privileged to welcome Professor Balasubramanian to today's session. It's quite an honor to have you with us, sir. Last but not the least, I welcome all the audience members to today's session. Without your valued and continued support, CIVINAR would not have flourished. Thank you. Over to you others. Hello. Others? I think some network issue is there.
Thank you, Mr. Kapuri.
Now, hello.
Now, I would like to request Mr. Pradeep Sarkar, sir, Professor of our Institute and the Chief Patron of the Organizing Committee, to say a few words on today's occasion.
Good evening to all of you. On behalf of the CEST club, as a faculty advisor of this club, I welcome all to this exciting session. It's really an honor for me and for the club to have Professor Balasubramanian among us today. Our club, this club started in 2012 for learning beyond the classroom, I would say. And they are doing excellent since this one decade, almost a decade, on different activities inside the institute and outside the institute. And recently this webinar series is attracting attention among the student community, civil engineering student community to be very specific. And I'm very grateful to Professor Balasubramanian for accepting our students' request to spend his valuable time. Thank you very much, sir.
Thank you.
Yes.
So, can I start now?
Sir,
No.
Pradeep Sarkar, sir, thank you. Now I request Professor Kakuli Karar ma'am for her address on this occasion.
Good evening. We welcome Professor Balasubramanian for this session. It is very exciting, especially for me because my research topic initiated with air quality. Air pollution is one of the major topic in pollution criteria because in terms of the accumulation in our body, if we compare and see air, water, soil, food, solid, etc., we consume maximum portion of air. And it is really excited to know so much thing about from an expert, well-renowned, eminent professor. I welcome from in view from NIT Rourkela, this eminent professor to proceed for this important speech. Thank you, sir.
Thank you very much, ma'am, for your inspiring words. Today, it is a matter of immense pleasure for us to be joined by Professor Rajasekhar Balasubramanian, Professor of Civil and Environmental Engineering at the highly prestigious National University of Singapore. He is also an adjunct research scientist at the National Center for Atmospheric Research, plus a member of the Science Panel of Asia Pacific Clean Air Program, and is on the board of directors of Asian Aerosol Research Assembly. He surely has numerous achievements to his name, and his contribution towards the field of environmental engineering are worth all the praise and much more. And now, in this session, he will be given an insightful and detailed talk on an unconventional topic, COVID-19 and air quality, and will unravel the knowns and unknowns. We lay a warm and heartfelt welcome to you, sir.
Thank you. Thank you for the introduction. Very good evening to all of you. I'm very happy to have this opportunity to interact with both faculty members and students at NIT Rourkela. Can I start my presentation now?
Yes, sir, you
All
can.
right.
And there's a message for our attendees. You all can send in your questions in the comment box and we can take them later. Thank you. So you can
All
go
right.
ahead.
Okay. Well, as you know, COVID-19 pandemic, it's currently a major global health crisis, which we're all trying very hard to tackle through collective efforts. And air pollution is a leading risk factor for increased mortality, rather excess number of premature deaths worldwide. So the question to answer here is, so what's the impact of COVID-19 on air quality, and what's the impact of air quality on COVID-19? So basically what I would like to do is to unravel this complex relationship between COVID-19 and air quality, and I will point out some knowns and some unknowns as well, which will provide a motivation for us to do more research to find the scientific answers. So COVID-19 is caused by SARS virus 2. As you know, it stands for Severe Acute Respiratory Syndrome Coronavirus 2. And the first few cases were identified in people living in Wuhan, China, back in December 2019. And the World Health Organization, WHO, declared COVID-19 a global pandemic in March, on the 12th of March. So since then, you could see a huge spike in the number of COVID-19 cases worldwide, as you can see the slide over here. And if you have a closer look at it in terms of the color code, you could see that we have a heterogeneous distribution of a number of COVID-19 cases in different countries within each continent. And we also have a different distribution of COVID-19 cases across different continents as well. Now, if we have a closer look at this figure down below, and the number of COVID-19 cases sort of increasing quite rapidly over the last 9 months over here. We have about 46 million cases worldwide as of 2nd of November. And the number of deaths attributed to COVID-19, it's about 1.2 million worldwide. So the question here is how to bend this curve, or how to flatten this curve in terms of reducing the number of COVID-19 cases. And again, of course, we want to reduce the number of mortality, the rate of mortality as well, the number of deaths. So we have introduced a number of proactive measures by announcing the lockdown in a number of countries worldwide. And some of the important lockdown measures imposed in different countries include restricted travel, both road travel and air travel, and also restricted mobility within countries. In addition to that, we have also imposed social distancing among people in different places. And we also increased telecommuting. So the idea here is not to reduce the level of productivity that needs to be maintained in commercial and educational institutions. At the same time, we also made it mandatory for people to wear a mask in a number of countries. So the question here is, with the introduction of all these lockdown measures, do we see a conceivable improvement in global air quality? This is what I'm trying to answer through my research. But before I talk about our findings, I just want to share some background information about the impact of air pollution on human health. Well, it has been documented by WHO back in 2018 that we have about 7 million excess or the premature deaths globally due to exposure to fine particles called PM2.5 that you find commonly in both outdoor and indoor environments. So in addition to that, about 9 out of 10 people living in cities globally inhale polluted air. The other part I want to highlight here is when it comes to climate change, most of the time we talk about the contribution of carbon dioxide as a greenhouse gas to climate change. But in addition to that, an important contributor would be black carbon or the soot that comes from the same source as CO2, mainly from the road traffic and also from industries that make use of fossil fuels. So when you have the incomplete combustion of fossil fuels, in addition to the emission of CO2, we also have the black carbon or soot, which also has negative impacts on human health. So what I have done in this research project is to download a number of papers published since the beginning of this year on topics related to COVID-19 and its impact on air quality. And as you can see in this slide over here, we have studied closely about 120 articles published since the beginning of this year. That is before lockdown, during lockdown, and after the post-lockdown periods. So we categorized the number of scientific articles published in the open domain or public domain according to different continents, as you can see over here, including Asia, Europe, North America, and South America. And there are some papers that talk about more than one country in terms of changes in air quality, and we call it global. So a quick background information about air quality. And as you can see the slide over here, a number of pollutants are emitted from a variety of sources, including anthropogenic sources, that is human-induced sources. So what we have done during the lockdown period was to sort of reduce the impact of human-related activities on air pollution, as shown here in this with the arrow, downward arrow. So basically we have restricted the urban mobility. We have also cut down industrial activities. So to some extent, we were able to reduce the emission of primary pollutants shown over here, including, for example, carbon monoxide, sulfur dioxide, nitrogen dioxide, and so on. At the same time, we have the natural sources of air pollution, which of course cannot be contained. And they continue to emit the same pollutants that are largely driven or largely emitted from anthropogenic sources. So the chemistry, kind of chemistry that takes place up in the atmosphere will continue to occur in terms of transforming reactive pollutants, which we call primary pollutants, into secondary pollutants, for example, ozone and some acids like nitric acid, sulfuric acid, and so on. Some of these pollutants are contained in particles which we inhale. So the particles we inhale not only contain primary pollutants like soot or black carbon, it will also have a variety of pollutants formed up in the air. And then the papers that we have reviewed closely over here have indicated the changes in air quality in a number of countries around the globe. So by and large, you could see that that's a significant improvement in air quality with respect to the concentration of primary pollutants shown over here. For example, PM2.5, and then oxides of nitrogen, sulfur dioxide, and so on. So all these criteria, air pollutants that are routinely monitored in different countries have gone down in their concentrations in response to the reduction in the intensity of human activities during the lockdown period. However, there are a few exceptions. And one of the exceptions is that the concentration of ozone, the secondary air pollutant, did not have an appreciable reduction in the concentration. In some countries, there's no change at all. And interestingly, in other countries, the concentration of ozone rather increased in contrast to the expectations we have had. So despite reducing the intensity of human activities, there seems to be an increase in the concentration of ozone in some countries. And the question is why? And this is a paper that was published from a well-known research group in the US. And what they did was to collect the air quality data across the US for several months, and then systematically analyze this data to find out as to what kind of changes in air quality happen, especially during the lockdown period. And what they have indicated in the paper is that both PM2.5, the fine particles, and the secondary air pollutant ozone were higher than expected. So that was kind of an interesting observation. And it turns out that the increase in the concentration of fine particles is mainly due to the formation of secondary pollutants, which is again induced by the kind of chemistry that's taking place up in the atmosphere. And again, ozone is also a secondary air pollutant, and that was also produced in larger amounts than expected under prevailing weather conditions. And then what I thought they have explained in the paper is that the kind of weather conditions we have, meteorology and the physical transport were not responsible for the increase in the concentration of both PM2.5 and ozone. So instead, the kind of chemical transformation that takes place up in the atmosphere is thought to be mainly responsible for the increase in the concentration of both PM2.5 and ozone. And that brings the next slide for discussion. So in this slide, you can see the kind of reactions that take place that will lead to the formation of ozone, the secondary air pollutant, and also the production of secondary aerosols in the atmosphere. So this could be a very kind of a complicated slide for you to understand. I will try to make it simple for you. And so this is the kind of a primary pollutant, nitric oxide, that will be emitted from combustion sources. And again, with the reduction in the number of automobiles on the road, and with reduction in the type of industrial activities, you would see a reduction in the concentration of primary air pollutant like NO, the nitric oxide. But having said that, there is still some amount of nitric oxide which will undergo oxidation, eventually forming the ozone that we are talking about, which is very harmful to humans because of the reactive pollutant. It causes respiratory problems, and it could also lead to asthma and other problems as well. But one of the key factors to consider here is the ratio of organic compounds to oxides of nitrogen. So the concentration of ozone produced up in the atmosphere is highly sensitive to the ratio involving organic compounds and NOx. So it turned out that during the lockdown period, despite having reduced traffic on the road and reduced manufacturing, especially in industries, this ratio of organic compounds and NOx changed. To be more specific, it rather increased. So the increase in the concentration of organic compounds led to the formation of ozone. In addition to that, when you have less primary pollutants like particles up in the air, you have more visibility. So with the enhanced visibility, we have more influx of solar radiation. And the solar radiation now will trigger the formation of ozone. So basically, the ozone formation is made more favorable because of less concentration of particles, which would otherwise reflect or scatter or absorb the incoming sunlight. At the same time, with reduced concentration of primary pollutant like NO, you don't remove the freshly formed ozone through this chemical reaction, which we call titration. So this reaction is suppressed. So the whatever amount of ozone that is freshly formed would remain for a sufficiently longer period of time with no chemical removal, with no physical removal as well. So that would explain as to why the concentration of ozone rather increased in contrast to the expectations we had during the lockdown period. And again, if you look at the particles over here, all these pollutants that are involved in the formation of ozone are also involved in the formation of secondary organic aerosols, which again increase the concentration of PM 2.5. So that's the bottom line over here. So to provide more evidence, there's another study that was reported, especially from the US, and you could see over here, prior to the lockdown period, he had an increased number of automobiles, business as usual, and we got a large fleet of passenger cars, trucks, utility vehicles on road. And of course, you would see increase the concentration of particles, increase the concentration of certain pollutants like carbon monoxide and so on and so forth. But again, during the lockdown period, you could see here there's a much larger reduction in the fleet of automobiles on the road. And this is reflected in the concentration of pollutants over here. And again, if we just count the number of vehicles and during weekdays and weekends, prior to the lockdown and during the lockdown, there is a significant reduction in the volume of vehicles. But what's more important is to consider the composition of traffic, the number of vehicles. And if you look at the composition over here, it's an interesting finding. So you see a larger reduction in the number of passenger cars, but you don't see a significant reduction in the number of heavy-duty vehicles like trucks, which are again involved in the transport of goods and services from industry, to consumers and back and forth. So that activity continued to take place, and that had resulted in some interesting observations. Like for example, and during the lockdown period, if you just count the number of particles that we inhale, there's a significant drop over here compared to the previous years. And again, if you look at the soot concentration that I mentioned earlier, is a significant reduction during the lockdown period as compared to the previous years. However, if you look at the ratio of soot, black carbon, to the particle counts, it rather increased. So the reason why there's an increase in the concentration of soot in particular is because are more heavy-duty vehicles on the road. In particular, we are talking about trucks and certain diesel-driven buses and utility vehicles still on the road, although there's a reduction in the number of passenger cars. And the other important finding came from China, and they have reported that the concentration of secondary aerosols that I mentioned before did not have increase, did not have a significant decrease in the concentration compared to other pollutants. So once again, the chemical transformation that usually happens up in the atmosphere was made more favorable because of less concentration of particles and more visibility up in the air. And one more important study that came from Seoul, Korea. And so over there, they have estimated the health benefits that are associated with the lockdown period. So we are again talking about reduced travel, air travel, and reduced road travel as well. And so there's a decrease in the number of deaths over here. This is the estimation over here, about 37 non-accidental deaths and 7 cardiovascular deaths and so on and so forth. But what's more important is that when people start wearing masks, and then they are more protected against inhalation of particles, inhalation of toxic air pollutants, that led to more significant health benefits. So this study clearly indicated the practical benefits in terms of protecting human health against air pollution by wearing suitable respirators or face mask. Okay, and then during the lockdown period, and of course we had no choice but to remain at home. So the question is, are we safe when we decide to remain at home? And there are some interesting findings that especially came from India. And if you look over here, and the intensity of indoor activities rather increased during the lockdown period, with more people occupying indoor spaces in residential homes. And of course, we do a lot of cooking, and we continuously clean up the floor with some detergent, with some chemicals. So there is some emission of chemicals from these activities in terms of mopping the floor and then using certain other cleaning agents over here. And with increased cooking of different types, there are more emissions of particles and other gases over here. And in places where people do smoking, of course, there are more emissions of other particles as well. So what is the impact of change in air quality during the lockdown period on potential human health effects? So this again, there are a number of papers talking about such health effects. For example, so one study that came from India that indicated that people, especially children, would be at an elevated health risk when they're exposed to increased concentration of air pollutants. And the reason is that the immune system of children is less well developed as compared to healthy adults. So they are more susceptible upon exposure to air pollution. And other interesting finding is that individuals who have the habit of smoking, again, they undertake a huge health risk over here by 14 times as compared to others who are not smoking. So smokers would have would experience higher health risk as compared to healthy adults in terms of exposure to indoor air pollution. And other important finding is that when people sort of burn incense as part of cultural or religious practices, they may not realize that is another important source of particles, another important source of air pollution, because the kind of smell we have could be misleading, and it's more like aromatherapy. I mean, you have the nice smell coming out of incense. We all think that, well, it's not a problem, it's good for us. But unfortunately, it's not the case, and we do emit particles, we do emit organic compounds. So whatever pollutants that you might find outdoors could still be found indoors because of increase in such indoor activities. And apart from that, people who have some pre-existing health conditions and the elderly whose immune system is relatively weaker would again experience elevated health risk as compared to healthy adults over here. So these are the points that are highlighted in the papers that we have reviewed. And another important question to ask is what is the mode of transmission of the so-called coronavirus from one person to another person? So the initial stages of this problem, COVID-19 pandemic, and people thought that the only mode of transmission of the virus was through the contact transmission, which is in terms of droplets. So when people sneeze or cough and so on, they excrete tiny little droplets. If the individual is already infected with the virus, and of course the droplets that are excreted by the infected individual would carry the infectious agents over here. So which could be deposited on certain surfaces and so on. So through contact, physical contact of such deposited droplets, one might be exposed to the virus. But later on, a number of studies have indicated that only contact transmission is only one mode of transmission. And what is more important is to consider the possibility of airborne transmission. And the reason is, again, is that when people exhale, and certain infectious agents could be excreted, which could undergo atomization, which will lead to the formation of tiny little particles. So in the case of droplets, the particle size could be more than 5 microns. Because they are more than 5 microns, they undergo sedimentation. Over here, they fall out very quickly, and they have very shorter lifetime. On the other hand, extremely smaller particles, which could carry the virus, they remain for a longer duration in the air medium because they're much smaller in size, and they could be transported over a longer distance. And the airborne transmission becomes even more important as compared to the contact transmission. And so that again would lead to the spread of coronavirus. And that's the reason why it's important for us to wear face mask. So by doing so, and of course we reduce the possibility of excreting such minor droplets, smaller droplets, and we also reduce the inhalation risk by wearing a mask again. So now going back to the question I asked, how come we have a heterogeneous distribution of COVID-19 cases among different countries within continent and among different continents over here. So that is the result of the effectiveness of mitigation measures that were adopted in different countries. So the countries that have adopted, for example, this quarantine or physical isolation, followed by social distancing and face covering with the use of a mask concurrently. When they adopt all these measures concurrently, they were able to contain the spread of the virus fairly quickly over here. And the countries, they had some delayed response in terms of recommending face mask and had a bit of a difficulty in containing the spread of the virus. And after some period of time, they were able to have some success. On the other hand, in countries where wearing the face mask is not made mandatory, and you could see here the number of positive COVID-19 cases rather increased. And so that clearly shows that the effectiveness of mitigation measures helps a lot in containing the spread of the coronavirus. Okay, so what are the practical measures that we could recommend, especially during the lockdown period when people remain at home? Well, and so we have two types of residential environments. So some of the buildings could be naturally ventilated and others could be mechanically ventilated. So when I say the buildings are mechanically ventilated, then of course we have air conditioning system over there. The air conditioning system enhances our thermal comfort. So we feel better when you turn on the air conditioning system. But the perception is that with better thermal comfort, the air quality is also good, which is not necessarily true. And so the perception is very different from reality. So we still may have a lot of particles. Who knows what? If there's an infected individual, we may also have some kind of particles carrying the virus and so on. So what's important over here, there are two important considerations to keep in mind. One is that we have to dilute the indoor air when the building is air conditioned or mechanically ventilated. To do that, we have to provide more fresh air after conditioning. So usually what people do is to kind of recirculate the indoor air in order to minimize the consumption of energy, which is a good idea, business as usual. But given the current concern about the global pandemic, we have to bring in the fresh air rather than recirculate the indoor air. At the same time, that leads to dilution. So when you bring in more fresh, conditioned outdoor air, and the kind of pollutants we have indoors will be reduced in concentration, leading to dilution. And apart from that, we also want to do the filtration of indoor air pollutants. So for that, we have to use high efficiency filters. And the high efficiency particulate filters are rated with ratings like 14 to 16. So usually people use MER rating of 7 to 8. So such particulate filters have lower efficiency in capturing smaller particles like fine particle PM 2.5. So in a condition like where we are in now, we have to use high efficiency particulate filter with a rating of 14 to 16. So the key recommendation here is dilution of indoor air with the supply of conditioned outdoor air. Together with filtration, we would have better indoor air quality. Now, at the same time, when in naturally ventilated buildings, of course, we keep the doors and windows open. This is one way of doing the dilution. On the other hand, if we use air conditioning unit, if we cannot change the filter like I was talking about before, so then we could use the portable air cleaners. So portable air cleaners are now available, and so it's important to use such efficient portable air cleaners together with some disinfectant devices, like for example, the UV light. The UV light could disinfect microbes if they are infectious. And on top of that, we are able to capture such smaller particles as well. So in naturally ventilated buildings, when we don't have an option of using particulate filter, to keep the windows closed and then use the portable air cleaners, preferably with disinfection devices like UV lamps. And one of the important considerations here is to make sure that the clean air delivery rate is as high as possible. So this basically reflects the amount of air that could be cleaned up by the portable air cleaner, and such information is provided by manufacturer. So we have to make sure that it's sufficiently large in order to clean up the rooms where the portable air cleaners are deployed. The other point to keep in mind is the electricity consumption. And what people have reported through research is in air-conditioned environments, indoor environments, if you look at the electricity consumption, it goes up during the day because of the need to condition the indoor air. And that leads to more emission of particles from power plants. So you are able to clean up the indoor air, but with the increased electricity consumption and the increased consumption of fossil fuels in power plants, there will be more emissions of particles, and therefore there will be deterioration of outdoor air quality. So it's important to make sure that we have to reduce the energy consumption in the context of improving indoor air quality. And the same thing is indicated over here in this slide. All right, and this is something that happened in Delhi, and so there's an article that was published in the newspaper, and so it's kind of smoggy these days from time to time in Delhi, which is not good because the exposure to PM 2.5 alone led to 24,000 deaths in the first two quarters of the year in 2020. At the same time, it also led to economic loss. We are talking about 20,000 crores or whatever. 5.8% of GDP is very high economic loss over there. On top of that, and again, there's an increase in the number of COVID-19 cases. So that clearly shows that there appears to be some kind of a linkage between deterioration of air quality and increase in the number of COVID-19 cases. So which means that the change in deterioration of air quality could be a risk multiplier in the context of COVID-19. So when we remain indoors, again, to summarize what I said before, we want to enhance the thermal comfort, and we want to minimize the cost of pollution control. We also want to minimize the energy consumption. This is we have studied, and we published a paper out of it. And you can see over here, just using the natural environment together with the portable air cleaner seems to be the best choice, rather than using air conditioning devices, because it involves more energy consumption. And so over here, with the use of portable air cleaner, you minimize the energy consumption, you enhance the indoor air quality, and there's no energy penalty. And that's the bottom line that I wanted to communicate with this slide over here. And again, you could see here, we are able to strike a balance in every aspect into the minimizing the health risk, enhancing thermal comfort, and reducing the cost of pollution control with the use of portable air cleaner together with a ceiling fan. When you have a ceiling fan on, it improves the movement of air, and with the use of portable air cleaner, you are able to clean up the pollutants and enhance the indoor air quality. Another take-home message here is we want to increase the level of active mobility in cities moving forward, and certainly the use of automobiles driven by diesel or gasoline would pollute the outdoor environment and causing increased exposure of pedestrians, cyclists to PM, which is not good. So on the one hand, we want to increase the physical, rather active mobility. On the other hand, we should cut down the traffic pollution. And so that's the kind of scenario we're talking about. So air quality should be considered in the context of enhancing urban mobility, with specific reference to the active mobility involving the use of cycles or walking, and so on and so forth. All right, so the other important take-home message here is when it comes to health risk assessment, quite often people think of outdoor air quality, but I have highlighted in this discussion, it's equally important to consider indoor air quality. So essentially, we want to make an assessment of our exposure to various air pollutants, including PM 2.5, both indoors and outdoors, continually on a daily basis in order to formulate effective policies based on which we would be able to improve air quality both indoor and outdoors. By doing so, we can reduce the health risk and provide better health benefits to the citizens. So we have to go from cities-oriented approach and move closer to citizens-oriented formulation of policies in order to citizens. And the last point I want to highlight here is, of course, a number of research groups in different countries are in a race to develop the vaccine. So at this point in time, and again, so it involves several stages. The conventional approach into the vaccine development will take several years. So given the gravity of the situation, the seriousness of the situation with respect to COVID-19, we want to speed up this vaccine development, and we take advantage of the advances in science and technology. And now we do what you call more like mRNA-based vaccine development. And there is messenger RNA. And so when you do the transcription of DNA to RNA, you will have the messenger RNA being produced over there. And this is what we are going to take advantage of. And that would contain the fragments of the viral genetic material. So that's a key over here in the vaccine development. And once you identify such the messenger RNA, and you want to encase it with a lipid membrane, and this is what is sort of injected to the humans then. And then when the vaccine gets into the human cell and the lipid membrane, basically it disintegrates, and then the mRNA, the single stranded RNA, is replicated, and that is basically will boost the immune system, and the immune system will sort of trigger a response when there is an invasion of the virus, like coronavirus, and in return, antibodies are produced in multiple numbers, together with possibly killer T cells, and that will basically enhance the immunity of the humans. So by doing so, we would feel rather safer, and this is a kind of a development that's currently taking place. So having said that, we have about more than a few hundred vaccine candidates being considered. They go through several stages in terms of seeking approval from health authorities, and that would involve clinical trials. And at this point in time, only 10 out of a few hundred vaccine candidates have gone to the phase 3. So in phase 1, the vaccine is administered to tens of or hundreds of people. The idea here is to find the safety of the vaccine, and the next stage is to assess the efficacy of the vaccine, and that is phase 2. Then it's distributed among thousands of people. Then in phase 3, we will go to hundreds of thousands of people to find out, how effective the vaccine is. This is the stage we are in now with, few vaccines. At the same time, we'll also give a placebo, and it's more like a control. So we compare the human response and in terms of administering the vaccine versus the placebo, based on which we could figure out, how effective the vaccine is. So Singapore is also involved in this effort, and we are getting into phase 3 at this stage. So that looks promising. So what are the policy implications out of the lessons we have learned? As I highlighted before, it's increasingly important for us to assess the human exposure to air pollutants in both indoor and outdoor environments, specifically PM, particulate matter, and fine particles, which are potential carriers of infectious microbes, for example, the virus we are talking about, COVID-19. And other policy implication here is, apart from improving air quality and human health, we also want to improve, we also want to mitigate climate change. So we are looking for co-benefits. We don't want to look at one issue at a time, and we have to find solutions to multiple issues, including improvement of public health and mitigation of climate change and enhancement of indoor and outdoor air quality. And this will be the future challenge for us. So the verdict, in summary, is air pollution is locked down by COVID-19, but not arrested yet. That means we still have residual air pollution problems. In some countries, you increase the concentration of ozone or PM2.5. So now imagine when business as usual takes place, then all the human activities that were curtailed through the lockdown would take place with more intensity in the context of improving the economic growth of countries, and then that will probably introduce even more air pollution than in the past. So the question here is how can we achieve sustainability by bringing all these concepts holistically is going to be the future challenge. So for which we are looking for proactive air pollution control and climate change mitigation policies being introduced concurrently based on scientific evidence. So with that, I stop here. Thank you so much. I welcome questions, if any.
Thank you, sir, for the insightful talk. Surely our viewers are benefited by the webinar. Now, without delaying further, I would like to proceed towards the question answer session, and viewers are advised to share their questions in the live chat sessions, and our speaker will be attending to them soon. So our first question is from Professor Kakoli Karar, ma'am. So, ma'am, you can directly ask your question to Professor.
Sir, thank you for such an interesting views about COVID-19, about air quality. Sir, you have beautifully explained the present scenario, its impact. So, few question I want to ask. Sir,
Sure.
due to lockdown, indoor air quality increases. Are there any steps so that we can improve the indoor air quality?
Indoor air quality gets worse. Indoor air pollution increases. Indoor air
Yes,
quality, yeah. So I see your point. So basically, what I mentioned before is that we have to do the source control first. So we have to identify the sources of indoor air pollution. So the
yes,
sources could be, for example, cooking. It could be incense burning. It could be use of kind of a vacuum cleaner, which may not be appropriate for the given situation, which might stir these particles and then resuspend them. It could go up, and the kind of chemical agents we are using. So basically, what we are saying here is like there are a number of chemicals that are used in indoor appliances and indoor products and so on.
yes.
And some of these organic chemicals, as they may have a sweet smell, but it could be misleading. We should not just go by the odor, but it could be toxic as well. So my suggestion here is to identify the sources of indoor air pollution and then restrict the presence of such sources and possibly eliminate them. That's the first approach. So sometimes, what might happen is indoor air quality may get worse because of what's happening in the outdoor environment. For example, it could be a residential apartment that's close to a road that carries a lot of vehicles, automobiles, and the traffic-related air pollution could migrate indoors, and it could affect the indoor air quality. So the question here is when there is when there is a lack of good indoor air quality, then where is it coming from? From indoors or outdoors or a combination of both, and how to eliminate the source of air pollution. The second approach is to mitigate the problem. So to mitigate the problem, like I said before, we got to do the dilution of indoor air. For us to do the dilution, the building is air conditioned, and of course you want to bring in more fresh air, and more importantly, you want to increase the air change per hour, ACH. So usually, when buildings are designed, the ACH tends to be about 2, or less than 2. So that means for every 30 minutes, the indoor air is replaced by outdoor air. But in COVID-19 kind of situation, we have to increase the ACH to 3 or 4 and so on. So bring in more fresh air After conditioning, you introduce it to the indoor environment that lead to dilution. In addition to that, we also want to use portable air cleaner in case the air conditioning units are not equipped with high efficiency particulate filter. So it's a multi-pronged approach we are talking about. And to start with, we should focus more on source, elimination of sources of air pollution.
Yes, sir. Sir, for that we need to do air source apportionment studies.
Not really. I mean, like I said before, these days we have a lot of wearable, portable PM devices. So we don't have to buy the bulky, expensive units. So you want to have a kind of a more like a sniffer, a small device that can sniff the air and will give you some rough indication of the level of pollution you have. And so, and such devices now are available. It doesn't cost much, and it doesn't occupy much space. Sometimes it could be battery driven, and if you could sort of use them indoors, and if you look at the profile in the concentration, that will give a clear indication as to where the pollution is coming from. And then if you just do it for a couple of days as a function of time, you might realize that the concentration increases in response to some specific human activities. For example, during cooking or during indoor air cleaning or whatever, right? So you don't have to do scientific source apportionment. And by looking at the change in concentration, the temporal variation of air pollutants, we can figure out where the pollution is coming from. Then it's a matter of mitigating such human activities in order to bring the level of air pollution to a very low level.
Sir, for natural ventilation, when we open the doors and windows, ambient air will enter inside the room. So is there any possibility that COVID-19 will transfer through air? Then there is a possibility that it will travel through air into our room also?
That possibility is not so strong because what matters here is the building occupant density. So when you have too many people in indoor environment, there's a potential transmission of the virus if there is an infected individual indoors. But from outdoor, over a longer distance, such infectious aerosols are unlikely to travel all the way from the outdoor to indoor environment. So basically, what we are saying here is like the social distancing is a good thing to do in the outdoors, but even indoors, to the extent possible, we want to practice social distancing to be precautious. Okay, and of course, if you're not interacting with the external community, it's just a family of 4 or 5, living together. If all of them are safe, it's okay, not a problem. But we don't want to have guests, as much as possible. We don't want to have visitors because we don't know their health status. And then if we happen to have any visitors, it's important to make sure that we practice social distancing. And of course, I would say that we would wear a mask before we even start interacting with the visitors, even while being socially distant.
Sir, last question. Sir, is there, when we exhale or inhale particles, we inhale or exhale a large fraction of PM, like PM1, PM2, PM3, up to PM10, then which size is more susceptible of infection for COVID-19? Any such particle size studies there?
It has been studied. Basically, the larger particles are retained in the nose or the upper respiratory system. So the usual response is to excrete them. They don't get into the lungs. So what's important here is to protect the lungs. Okay, so when you have high concentration of ozone, it affects human lungs. When you have a high concentration of particles, especially fine particles like PM2.5 or smaller, they continue to travel all the way into the alveoli region. And so this is where they could be deposited, the fine particles. They are not retained in the nose or the upper respiratory system. So the smaller particles could be also potential carriers of the virus because they're smaller. and they are long-lived. And then if they happen to be deposited over there, and there's a potential impact on the lungs. So the particles initially will cause inflammation. But when you have, any infectious agents like coronavirus or whatever, it will have entirely different effect. So what we are concerned about is a synergistic effect of having smaller particles which will cause inflammation, and together with infectious viruses, then the effect will be more detrimental. So what we are concerned about is the capture of smaller particles, and we don't want to inhale such smaller particles. And that's why I recommended the PM filter with a MERV rating of 12 to 14, because particulate filters with MERV rating of 12 to 14 are primarily designed to capture smaller particles. But if we have smaller rating like 7, MERV rating 7 or 8, they're designed for capturing bigger particles, which is not going to be effective in the current situation.
Thank you, sir, for such a valuable and interesting expressions and ideas sharing with us.
Yeah.
Thank
you for the questions.
Thank you, sir. Sir, our next question will be asked by Professor Pradeep Sarkar.
Sure.
Sir, please ask your question. Sir, are you there?
Sir, I have some general question.
Sure.
Our government of Odisha has banned the firecracker to stop the Diwali pollution.
Yes.
And this is specific for the COVID pandemic situation. So what is the relation in that?
Okay. I would say even in the absence of COVID-19, it's not a good idea to use firecrackers.
Yeah, that is true. But what is the specific?
Sorry, I missed the question. What's the specific?
I mean, is there any specific link between the COVID pandemic and this air pollution for associated with this Diwali?
Yes, of course. I mean, exposure to particulate matter particles emitted from fireworks is going to cause, some health problems, especially for children, and then for the elderly or adults with some pre-existing health conditions. So their immune system is going to be weakened upon exposure to such toxic particles. But on top of that, if they ever happen to be exposed to this infectious virus, the effect will be more detrimental. So that's the reason why we want to reduce our exposure to air pollution as much as possible as a precautionary measure. And that's the reason why the lockdown measures were, recommended. But on top of that, social distancing together with the mandatory wearing of facial mask or respirators would be very effective. And this is what the studies have clearly indicated. The countries that have made social distancing mandatory together with the wearing of facial mask have been able to contain the spread of the virus more quickly and more effectively than other countries that did not recommend such strict measures.
Okay, sir. Okay, thank you, sir.
Thank you.
Thank you, sir. Yeah. Sir, we'll next pick the questions from the audience that has been asked in the comment box.
Sure. Let me see if I could.
Yes, sir. So there is a question from Mr. Abhishek. What is the effect of climatic conditions on spread of virus? And does a warmer climate really help in slowing down the spread rate?
Okay. Can you repeat the question, please?
Okay, sir. Sir, the question is, what is the effect of climatic conditions on spread of virus? And does warmer climate really help in slowing the speed rate?
Okay. Well, I mean, that's an interesting question. In terms of climatic changes, and we are mainly concerned about the winter season and compared to summer. And the reason is that during the winter season, of course, the mixing of air is highly inhibited, both horizontally and vertically. And with the reduced influx of solar radiation sunlight, the wind speed decreases. With the decreased in wind speed, you got less dispersion of air, polluted air. So with the reduced dispersion of polluted air, you have more accumulation of pollutants. Okay, so that's going to affect your human health. So even the absence of COVID-19, and if you look at the number of patients or people who have some pre-existing health diseases or ailments upon exposure to air pollution, such cases would rather increase during the winter season as compared to summer season. And mainly because of the increase the concentration of particles, concentration of air pollutants with less dispersion and more inhalation of such particles. So now with the case of COVID-19, so there's a possibility that the effect could be more severe than usual, meaning that during the summertime or springtime and so on. So there is a kind of an indirect linkage with the change in weather conditions and the spread of COVID-19 and its impact, and more importantly, its severity on the health of people who are exposed to the virus.
Thank you, sir. We have our next question from Mr. Nisant. What are
Yeah.
your views on replacement of usual petrol and diesel vehicles by electric vehicles? Do you really think it will help in reducing pollution and improve air quality?
That's an interesting question. The near term, yes. The long term may not be. And the reason is that the near term, we are talking about improvement in air quality. And if that is your primary concern, or it's your primary criterion in terms of improving air quality, and of course, phasing out fossil fuel cars and replacing them by EVs would certainly help. But having said that, there is going to increase the demand for electricity because you have more electric vehicles on the road. And the next question is, how is electricity produced? The electricity is still produced by the use of coal or oil or even natural gas. There is going to be an increased emission of particles, increased emission of pollutants, and certainly carbon dioxide. And that is going to accelerate global warming. So on one hand, you are able to improve indoor air, you are able to improve urban air quality. On the other hand, there is still, we contribute to increase to global warming because of the emission of carbon dioxide, the case of natural gas. So the use of EVs would be beneficial if we switch to renewable energy. And the renewable energy, of course, we produce a number of ways. And so if, for example, if you are able to produce solar energy, if you are able to do 100% solar energy, the city, wherever you are, then the use of electric vehicles is okay. It's not a bad idea. But having said that, now there seems to be more evolution in technology. Now we are talking about hydrogen. And so we are talking about green hydrogen in particular. And so if you are able to produce hydrogen out of the electrolysis of water, that is going to be the real future, because you are not emitting any carbon dioxide and you are not emitting any other pollutants, but instead you are making use of water and you split it with the use of solar energy to make hydrogen, the cleanest fuel you could think of, and the byproduct you get is water, and then that could be recycled and recovered or whatever. Going further, as I mentioned in my talk, I would rather recommend the active mobility if possible. So we can go cycling, we can go walking, or you can share cars, an EV car, for example. So we have to change our lifestyle. Individuals matter a lot. So through the collective efforts of individuals who don't mind changing their lifestyle in the context of sustainable development, a lot of environmental problems that we have been talking about and we seem to be experiencing over the years can be resolved. So to answer your question, use of EVs in place of fossil fuels is better in the short term. The long term, it's not a very good idea.
Thank you, sir. We have our next question from Mr. Soumya Ranjan Sahu. Will the short-term reduction in air pollution that appears to be emerging during the lockdown result in improved health?
Certainly, and that's what I have highlighted in the slide that came from Seoul, Korea. So basically, they have estimated health benefits in response to the reduced traffic on road or reduced impact of human activities, to be more specific. And then what they have documented in the paper is there will be a larger reduction in the number of premature deaths because of reduced concentration of air pollutants. But even then, if one could wear a mask that provides additional layer of protection against exposure to air pollution. So despite having a lower concentration of air pollutants, by wearing a face mask, you have nearly 100% protection because you don't inhale any pollutants at all. So ultimately, the health effects is a result of two factors. So one of them is the concentration, the other one is the toxicity. So you may be having a lower concentration of pollutant, but if that pollutant is very toxic, the health effect could be still significant. So by wearing a face mask as a mitigation measure, you protect your health by minimizing your exposure to toxic pollutants. So this is going to be like the new normal. So like, for example, in the case of Singapore, we can manage to reduce the number of COVID-19 cases, and yet we don't think of not wearing the mask as an option. We want to continue to wear the mask for a while, because that seems to be the best way to go forward in terms of minimizing our exposure to air pollution, because it's going to take quite some time for us to significantly improve air quality in any part of the world. So having said that, there could be some little bit of practical inconvenience, but it's a matter of getting used to it. And so once you get used to wearing a face mask, it becomes part of your routine, and that provides a lot of health benefits. So to answer your question, yes, reduced air pollution during the lockdown period, it's having a positive impact on improving human health.
Thank you, sir. The next question is from Satyadeep. Is there any compound that can be added to concrete mixture during the construction to improve the indoor air quality?
Okay, there are there's something called self-cleaning walls. The concrete wall as such, may not be able to clean up air pollutants. But on the other hand, if you can add something like titanium dioxide, it's a chemical, it's a semiconductor, and that can absorb the light. But having said that, if you can make titanium dioxide that can absorb the visible sunlight, is a big plus. So then there are pigments now available, and so the pigments would contain such chemical additives like titanium dioxide that have a tendency to absorb the visible sunlight. By doing so, it can sort of trigger the destruction of pollutants, which could be deposited onto the walls. For example, exterior walls in a building. So then, like for example, the Taj Mahal, and it's no longer white. Okay, that's been exposed to a lot of pollution in Mathura, and that's why you have the discoloration. Correct. So likewise, we have to prevent the problem. So it's a challenge for civil engineers. So when you do the material synthesis, so how do we alter the properties of materials in such a way that the walls being constructed would have the capability of self-cleaning themselves against exposure to air pollutants? And so such concrete mix is being explored in a number of places, but it's not reached a stage yet where it can be commercially available. The other important problem is corrosion. So when you have a steel bar as a reinforcement, and these days because of climatic conditions, changes in humidity, changes in rainfall, and so on, and buildings can undergo corrosion. It could be chemical corrosion or it could be microbial corrosion. So then you want to have corrosion-proof kind of materials. And again, you can add some chemical additives, and these chemical additives will provide additional layer of protection against corrosion-related problems. So this is again work in progress, and because we are concerned about the impact of climate change. So on one hand, we want to mitigate climate change. On the other hand, we also want to be prepared to adapt ourselves to the changing climate. So in that context, the question is valid. So we have to alter the properties of concrete, and in fact, even while making concrete, you want to reduce the level of consumption of fossil fuels. So now people are talking about having a different concrete mix, and with the man-made, waste materials being added in place of cement. So that's such man-made binding materials who have the same property as cement, and then cement manufacturing is highly pollutive. It emits a lot of carbon dioxide. To start with, we can do that, and later on, you want to alter the kind of composition of binding materials by adding some chemical agents that can provide protection against the corrosion and any kind of degradation because of exposure to air pollution.
Thank you, sir. We have our next question from Mr. Ajay. He's asking, is there any compound that can be applied on multi-storied building to absorb black carbon aerosol specific?
Okay. And again, it's a matter of, it's a good question. It's a matter of adding chemical additives. And so there are some chemical compounds, like for example, graphene-based materials. And so there are some graphene-based materials that have they have a tendency to absorb the visible light. And then what's going to happen is, like, if there is any deposition of soot or whatever, and they could be sort of washed out on one hand. That's the easiest thing to do. We wash buildings from time to time, and then so you want to have some kind of a property of the material, the construction material, which may not retain the soot, for a longer duration, and so it will simply attach it to the surface rather weakly, not very strongly chemically bound. So then you could sort of spray water and you can wash it out. This is one way of doing it. But to degrade soot is possible. There are some ongoing research in that area, but it would depend on what kind of soot particles we have, and how much is deposited, and where is it coming from. Soot properties also vary. So the one that comes from coal is going to be different from the one coming from oil combustion or other sources. So there is no silver bullet, so to say. So I cannot give a recipe that would indicate that the soot will be degraded upon deposition onto the building. That requires innovation. For innovation to take place, we have to do more R&D that is locally relevant.
Thank you so much, sir. We have asked most of the questions that was given in the comment box by the audience. Now I'd like to invite Mr. Subham to give the vote of thanks on behalf of the CEST Club of NIT Rourkela and IC UK NIT Rourkela chapter.
Well, thank you, Armande. Good evening, everyone. Myself, Subham Das, a BTech third-year undergraduate from the Department of Civil Engineering of NIT Rourkela. I am one of the organizing secretaries for the event CIVINAR. Let me start by saying how grateful we are towards Professor Rajasekhar Balasubramanian from the National University of Singapore for taking his precious time and effort to deliver his webinar on COVID-19 and air quality. His contribution and research in the field of environmental engineering, air pollution control, sustainable development is quite remarkable. His research has helped in the understanding of the environmental and health impacts of air pollution on scales ranging from local to global, and to develop cost-effective technologies and formulate regulatory strategies to mitigate these impacts. I am sure, sir, everything you told us today will be of great use to us all someday. Now, I would like to thank Professor Pradeep Sarkar, sir, the faculty advisor of ICE UK NITR chapter, and Professor Kakoli Karar Paul from Department of Civil Engineering for joining us and gracing our webinar from their presence. Their
Thank you,
constant
Shubham.
has been and will be indispensable. I would
Okay.
also like NITR and SAC for giving us this chance and such constant encouragement to do such events which will help us grow and develop. And of course, the webinar would not be complete without its lovely audience. Thus, I would like to thank you all for attending and making it a success. Last but not the least, I would like to thank the organizing team for their tireless effort into making this event possible and seeing it through. Thank you all for turning up for the session. We hope all of you are keeping safe and doing well. We will have the sixth session of CIVINAR scheduled to be on 20th of November, in which we will be joined by Professor Ayan Sadhu from the Western University, Canada. He will be delivering his talk on failure assessment of structures. So stay tuned. The video links of our previous sessions are provided in the description. You can go through that and don't forget to subscribe our channel. Thank you again.
Thank you, Shubham, for your kind words. I also want to thank the organizing committee for inviting me to deliver this webinar. And it was a great pleasure for me to interact with all of you. It's just a starting point, and of course, we will continue to interact whenever possible. And do not hesitate to contact me if you need any further help. And more importantly, stay safe, stay healthy, and stay self-motivated.